In today's lecture, I'm going to talk about changes in air pollution since the middle of the last century, and what has created these changes. By the 1950s, air pollution was very visible with frequent thick black fogs known as smogs in many large cities around the world. The main source of this pollution was from factories, and it caused severe health problems. For example, a particularly severe smog in London in 1952 caused over 4,000 deaths. Obviously something had to be done, and in 1956 a Clean Air Act was introduced in Britain. This addressed the pollution from factories and the smog soon disappeared. However, as you know, these days air pollution is still a big issue. The main difference between now and the 1950s is that you can't see it, it's invisible. Also, the main source of pollution now is from cars and lorries, and although these don't produce visible signs, this air pollution is still a significant risk to health. And one of the key factors in the rise of this type of pollution is that we have all become much more vehicle dependent. There are far more cars and lorries, trains and planes than in the 1950s, and this is now the main source of air pollution around the world. Supersymmetry is a mathematical idea that people have developed an effort to understand the sharpest organizing principle for the fundamental constituents of matter. You see, we have learned that particles that seem to be different can actually secretly be united by certain symmetry principles. So we use the fact that there are symmetric objects in the world like a sphere or basketball. You turn a sphere and even though you've transformed it, it looks the same fundamentally. We found that certain particles, when you transform one particle into another, even though looks like the identity of the particle has changed, overall the equations describing it, they don't change at all at an underlying level of symmetry. But we've not been able to do is find a symmetry that would relate certain kinds of particles, namely matter particles and force particles. Matter particles are particles like electron, muons and quarks. Force particles are like photons and gluons and WZ bosons. Supersymmetry is a symmetry that actually relates to these two classes of particles. And people have proven that supersymmetry is the last possible symmetry of the fundamental particles that are mathematics. Reality has not yet been shown to make use of it. We actually have seen more than one of these black holes emerges, and we've seen actually two about equally good, although the one that we talked about you can see with your eyes. The second one is the one with the lighter black holes in it. They're not so heavy, when the ringing is a lot longer, and you can see it without all the fancy data analysis. Then there is a third source which we've already published, but now that we have seen that two of the other one, and we also believe that could very well be black hole theory, So we have 3 sources, let's call it 3 sources in 3 months. Now if we make design sensitivity, we have improved apparatus by another factor of 3. Now how does that translate into rate? It turns out if you look with a sensitivity 3 times better than we have, you can look 3 times deeper into the universe. That says the volume of the universe that you are looking at is 3 to the q, so that's about 27 or 30 around the universe. So instead seeing one a month of these black hole periods, we should see maybe one of every 2 days, one every day. That's gonna change the character of how we operate completely. Across the world people have been watching the choice that Britain has made. I would reassure those markets and investors that Britain's economy is fundamentally strong, and I would also reassure Britons living in European countries and European citizens living here that there will be no immediate changes in your circumstances. There will be no initial change in the way our people can travel, in the way our goods can move, or the way our services can be sold. We must now prepare for a negotiation with the European Union. This will need to involve the full engagement of the Scottish, Welsh and Northern Ireland governments to ensure that the interests of all parts of our United Kingdom are protected and advanced. But above all this will require strong, determined and committed leadership. I'm very proud and very honored to have been Prime Minister of this country for 6 years. I believe we've made great steps, with more people in work than ever before in our history, with reforms to welfare and education, increasing people's life chances, building a bigger and stronger society, keeping our promises to the poorest people in the world and enabling those who love each other to get married whatever their sexuality, but above all restoring Britain's economic strength. There are 4 fundamental forces at work in the universe. Some of them are very familiar from everyday life, some of them are not, so we all know about gravity. That's one of the 4 forces. It's what keeps us ankles to the surface of the Earth, keeps the Earth in orbit around the Sunday. There is another force that we're very familiar with, which is the electromagnetic force, that is the force that is responsible for the electricity, electric currents for light, for the sun's light, that's electromagnetic radiation coming from the sun to the Earth. There are 2 other forces though, that are somewhat less familiar. They are the nuclear forces. They are forces that are at work within the nuclear atoms. One of those forces is called the strong nuclear force, that really is the force that binds protons to proton, binds the quarks inside of the protons and neutrons keeping them from flying out. The other nuclear force is called the weak nuclear force. And that's a force that predominantly we know of because it's responsible for radioactivity, radioactive decay. So those four forces: strong nuclear force, weak nuclear force, electromagnetic force, and gravitational force, those are the forces that work in the universe. A dimension of space is basically an independent direction in which in principle you could move, you could walk. So we talk about left and right. You can freely move left, right, back, forth. You can move back, forth, up, down. You can freely move up, down as well. If you consider a diagonal direction, that's not a new direction because that's just a combination of moving this way and that way. So when we talk about dimensions, we talk about the independent directions which you can move. Another way to think about dimensions: they are the data that needs to be specified in order to delineate where something takes place. So if you're having a dinner party, you give your friend a straight, a cross, straight in the floor number, 3 pieces of information to nail down a location in 3 dimensions in the space. According to the string theory, in reality you need to give your friend more than just those 3 pieces of information if you really want him or her to know where to go. You need to tell them coordinates, data that specifies real actual dimensions the dinner party's taking place too, but because the actual dimensions we think are so small, it does not matter to your friend. One other keys to Apple is Apple's incredibly collaborative company, and so you know how many committees we have in Apple. 0. No committee. We are organized like a startup. One person's in charge of iPhone OS software, one person is in charge of Mac hardware. One person is in charge of iPhone hardware engineering, another person is in charge of worldwide marketing, another person's in charge of operations. We're organized like a startup. We're the biggest startup on the planet, and we all meet for 3 hours once a week, and we talk about everything we're doing, the whole business, and there's tremendous teamwork at the top of the company which filters down to tremendous teamwork throughout the company. And teamwork is dependent on trusting the other folks to come through with their part without watching them all the time, but trusting that they're gonna come through with their parts, and that's what we do really well. And we're great at figuring out how to divide things up in these great teams that we have and all work on the same thing, touch bases frequently, and bring it all together into a product. We do that really well, and so what I do all day is meet with teams of people, and work on ideas, and solve problems to make new products, to make new marketing programs, whatever it is. This week I'd like to start by talking a bit about electric vehicles. Although we tend to think of electric cars as being something completely modern, they were in fact some of the earliest types of motorized vehicle. At the beginning of the 20th century, electric cars were actually more popular than cars with an internal combustion engine, as they were more comfortable to ride in. However, as cars fueled by petrol increased in importance, electric cars declined. The situation became such that electric vehicles were only used for certain specific purposes, as forklift trucks, ambulances, and urban delivery vehicles, for example. Although electricity declined in use in road vehicles, it steadily grew in importance as a means of powering trains. Switzerland, for example, was quick to develop an electrified train system, encouraged in this no doubt by the fact that it had no coal or oil resources of its own. Nowadays there is renewed interest in electricity as a means of powering road vehicles. Why is this the case? Well, undoubtedly economic reasons are of considerable importance. The cost of oil has risen so sharply that there is a strong financial imperative to look for an alternative. However, there are also environmental motivations. The internet is changing everything. The world of language in the future is totally different from the world of language in the past, and the reason is quite simple. There is more written language on the internet now than all the libraries in the world combined. We've never seen anything like it before, and we haven't seen anything yet. When you're talking about the future of a language, we are asking about its long-term prospects. Where do they essentially lie? And my answer is they lie in the young people, they lie especially in the hands of teenagers. The teenagers are the parents of next generation of children. If teenagers are going to succeed in maintaining the intergenerational transmission of a language, then they have got to be infused about the minority language, the endangered language, that their parents and others speak. So how would you get teenagers infused is the question. Well, there is no question today, the only thing that infuses teenagers, apart from sex, is internet and all the electronic world. And so that is the area where one has got to focus. A minority language has got to get itself up electronically in all the varieties that are available to it. What I want to look at today is the question of how much technology, if a pen can indeed be called technology, perhaps I should say the instrument of writing, affects a writer's style and level of production. I also want to consider other factors that may have an effect on prose style, such as personality, educational background, and so on. Now, production levels aren't so hard to measure in relation to the writing instrument used. The quill pen, for instance, would need continual refilling and resharpening, which led to a leisurely, balanced style of prose full of simple sentences. Writing took a lot longer than now, and the great novelists of the 18th century, Fielding, Smollett, Richardson, had a relatively small output, though some of their books ran to enormous length. By the middle of the 19th century, the fountain pen had been invented. It didn't need such constant refilling, which can account for the more flowing, discursive style of, say, Dickens and Thackeray, as well as their tremendous output. Then came the typewriter, whose purpose, once you got the hang of it, was to speed up the writing process, and was therefore much favored by journalists. This, it seems to me, gave rise to a short-winded style characterized by short sentences. Now, you might think it strange that in a lecture on biology, I will be talking a lot about mathematics. If I may digress a bit. When I was a student, mathematics, the language of dear abstraction, had nothing to do with life sciences like biology, the sphere of messy organic forms, cutting up frogs in the lab, and so on. In fact, I started doing biology precisely to avoid math and physics. So, I've had a lot of catching up to do. We are all aware of how the sciences have come to interrelate more and more, and not only will mathematics impinge more and more on biology, but also, I am told, in the 21st century, the driving force behind mathematics will be biology. This is partly because mathematicians are always on the lookout for more areas to conquer. But a far greater reason is that the subject has been boiled down to physics and chemistry, obvious attractions for mathematicians. A number of mathematical fields can be applied to biology.